OK，有一个东西我漏了啊，有一点点东西，就是当我们 mark 那个 point 的时候啊，let's say，OK，如果你看这个图是 solid line 是 crest 啊，dotted line 是 trough，OK，so this is the top view of the waves 啊，solid line is crest，OK，so here x 就是 OK，我们 mark constructive interference 啊，so solid line 跟 solid line，或者 dotted line 跟 dotted line 对吗？对，这样子我可以 mark 这样子。通常你会发觉到是它们是一条线，它 form 一条线的，你看。如果你觉得很难要 mark 啊 ，let's say 如果 exam 它叫你 mark 了 ，OK， 你觉得很难很复杂要 mark 的话，你 mark 了一个 point 是你看下去，你看好像一条线这样，因为通常它们都是一条线，OK， 所以你看这个 x 啊，下一个就是 dotted 跟 dotted， 下一个就是 solid 跟 solid，dotted 跟 dotted，solid 跟 solid， 这个也是一条线，一条线，一条线，这里，这里，这里。Okay, yeah, I'm going to mark a few only lah. Okay, yeah, it will be very confusing here. Too much. Okay, so the point is that when you mark all the points, you connect it with a line. 你用一条线来 join 它 you connect it with a line. This is we call the anti-nodal line. Okay, anti-nodal line. Anti-nodal line 是一个 line 它 join 全部那种 anti-node。Okay? Again, anti-node 是什么 constructive 的。Okay? Anti-nodal line 是 join 全部 anti-node。然后在那个 anti-nodal line 的旁边罢了就是 OK mark star， 这个是 destructive， 这个 star， 这个 star， 这个 star， 你找那种 solid 跟 dotted line 碰到的啊，那个就是 destructive 啊 ，destructive。Okay, so you find that there's a line between the anti-nodal line here, and if you draw like this, it has a line like this. Okay, so 那个 black line 呢，我们叫 nodal line. The black line is the nodal line, and the green line is the anti-nodal line. Okay, this one I'm not going to talk more about it. You can just read up in the book. Okay, we can save some time for this one. Anti-nodal line and nodal line. So you connect all the points, then you get the line. Okay, so 刚刚那个我修你的那个 constructive 的那个照片呢，这个照片呢，这条线呢是 anti-nodal line 来的，因为全部这种都是 constructive 嘛。OK， 这个是全部是 anti-nodal line。Okay, now we are moving to the last part of the interference. The last part. Now, last part is the formula for interference. Okay, the formula for interference. But I'm not sure whether your teacher will include this in your exam or not. Okay, but according to your textbook, yeah, it is inside your textbook. Okay, but I'm not sure your teacher will give you this one. But I'm going to just spend a couple of minutes to talk about it. Okay, now the formula for interference 就是okay, so how do I say this? Lambda 等于 ax over d. OK， 只有一个罢了，就是这个罢了。Lambda 等于 ax over d. Now a 呢就是 the distance between the source. OK， 所以你看这个 spherical dippers the distance between 这两个 dippers 那个就是 a. This is a. X 就是 the distance between each of the constructive interference line. For example, let me plot this. This is constructive. Here, and here, right? All this. In fact, if you put a screen here, yeah. If you put anything like a screen or anything here, usually they'll put a screen for light, because this is water waves, right? Okay. So if you put a screen here, then you will see that the distance between each constructive interference line, and this one is the x. This is x. Okay, distance between the constructive line. 这个是 x， 然后它是一样的，它是一样跟这个也是 x， 这个也是 x， 它是全部都一样 distance。Between the distance between each successive lines, they are the same. OK， 那个就是 x 啊 ，d 呢 ，d 就是从你的source。Okay, so let's say this is your source. I draw a line. This is your source to the screen. The distance. Okay, from the source to the screen. This is the distance d. Okay, now 平时问题会讲问呢，他就讲 OK, calculate the frequency of calculate the wavelength of the wave. Then you use this formula. Okay, so to find the wavelength is equal to you take the distance between the two sources, you times by the x, and then you divide by the distance. That's it. Then you can find the wavelength of the wave. So all these waves, they have the same wavelength and the same frequency because they are coherent. Okay, now, yeah, later I'll give you try out three examples of this one. Okay, now the last part is the diffraction and okay, so far we talked about diffraction, and then we also talked about the interference, right? Now we look at previous example I show is for water and sound, right? Water and sound. Now last one we look at light. Okay, light. Just I'll spend a couple more minutes. This one. Okay, so for light, this is a very popular question. A very popular question. Always came up in the final exams several times. So Young's double slit experiment. Okay, now Young's double slit experiment 是一个 Young 是一个 scientist 来的。Okay, now 这个 scientist 他 study 那个 light， 他 study 那个 diffraction and interference of light， 然后他把他的 experiment 称为 the double slit experiment. Okay, so here you see the formula is the same. Just now we talked about that formula, right? So basically how this works, you see 这里我们有一个 monochromatic light source. 什么是 monochromatic light source? 你可以把它想象成一个 laser. Okay, laser 它只有一个 color 吧，一个 color 一个 frequency， 它就是 monochromatic. Okay, so red laser, green laser, as long as it's laser, it's monochromatic. Okay, now basically 这个 Young 这个人呢，他拿一个 monochromatic light source 他照去这个写错了这个是 single slit 来的。Okay, now guys, pay attention, be careful of this one. This is actually single slit, not double slit. 一个 opening 吧，它只是一个 opening， 所以它是 single slit. 所以这个 light 呢，它照去这个 opening, and then what happens? Diffraction will happen. Okay, diffraction will happen. So I draw it here. The light will spread like this. Let me zoom in. This is very hard to see. Okay, this is better. Okay, so here, after the single slit, diffraction happens, right? Because just now we learned about diffraction. When the waves passes through the opening, it spreads. So here it spreads, and here you have another double slit here. Okay, now 这个 double slit 呢，有两个洞啦 ，OK， 有两个洞，然后 the distance between the 洞the slit is A, right? Is A, just like the distance between the source. Okay, so we are treating the slit as the source of the interference. Okay, 所以 first step 这里是 diffraction, 然后这里是 interference. Here and here. All right. Okay. I'll explain again. So after the first single slit, the waves diffract, right? Diffract is spread out. Now, after passing through the second slit, the waves interference will happen. Okay, like this, and then this one like this, like just now. You treat the slit as the source. 你把那个 slit 当作那个 source， 就很像我们的 speaker 这样子。Okay, now, so what he observed 他看到的他的 observation 是什么？他看到这个 screen， 如果他放一个 screen 在前面， 它会看到有一线白、一线黑、一线白、一线黑，这种我们叫什么？这种我们叫 fringes，like bright and dark fringe. Okay, now the red one is the bright one. The red one is the bright fringe. The dark one is the dark fringe. Okay, bright and dark fringes. So why do you see this? Same thing as the interference of the sound wave just now, right? You see the interference of the sound wave. 你是 from 那 interference 啊，我们拿到一线 constructive 对吗 ？OK， 所以这种红色的呢 bright light 啊，就是那种一线的 constructive interference。OK， 那个黑色的那个一线是 destructive interference。OK，so question exam 他会问你 ，OK， where is the constructive interference? Then you have to know, okay, the red one is the one. Okay, usually in objective lah. Okay, where is the destructive interference? The black one. Okay. All right, now, 所以你看到 x 就是 the distance between the constructive interference and the next constructive interference, x. So this is the same as the formula just now. So x is the distance between the constructive and destructive. Sorry, the constructive and the next constructive. D, what is the D? The D is the distance from the source to the screen. This one. Okay, so overall, 这个我们叫 Young's double slit experiment. 为什么他要做这个 experiment 的主要 purpose 就是什么？是它的 finding 啊，它的主要的 finding 是什么？这个 experiment 它 prove 了 light 是 wave。OK， 因为你记得吗？我在 diffraction 那边我有讲到是只有 wave 可以 diffract， 还有 interference，right? It all happens on wave only. So if light can happen like this, meaning that light is a form of wave, right? But previously, what we learned about light is we think that light is a line. Light is a line. It's like a ray, a straight line. Actually, in reality, a light is not a line. We draw it in a line just to simply represent it for simplicity. In the reality, it is a wave. Okay, light is also a wave. So again, question will ask you, okay, what is the finding of this experiment? You say to prove that light is a wave. Okay, to prove that this experiment is to prove that light is a wave. Okay, now a few more. So from here, Young's double slit. 所以我可以 increase 那个 okay, sorry, let's look at this one first. Okay, this one requirement for the interference pattern to be observable. Okay, 所以它有一些 requirement 呢 for 如果我要看到这个 bright and dark fringes 我一定要 fulfill a certain requirement. First thing, what are the requirements? First thing is that you have to make sure you use a monochromatic light. Okay, you use a monochromatic light. First one. If you use normal light, then you won't see it. You won't see it. Okay, because normal light you have many different frequencies. Okay, and the energy, it will lose energy. Okay, so you cannot see the bright and dark fringes. The second one is the size of the slit need to be very small. Okay, 你看这个 single slit 它其实是很小的 about 0.5 millimeter. 为什么它要这样小呢？你看记得在 diffraction 刚刚我们讲到什么吗？ diffraction 的时候 ，diffraction 我们讲到那个 diffraction of opening 的话是 ，okay, this is the waves coming, the incoming waves, right? So this slit in the Young double slit experiment 他们会用很小的 slit opening that is almost the same as the wavelength. Okay, that is almost the same as the wavelength. I repeat, the distance over here between the opening is almost the same as the wavelength of the laser light. So what happens if they are the same? If this is B, if this is D, what happens just now? Right? If the wavelength is the same, you get what? You get a circular wave, right? You get a circular wave and it spread outwards even more. Right? So this is the same thing happened in the light, the Young double slit experiment. Okay, so we want to use a very small slits, not necessarily exactly the same as the wavelength of the red light. Okay, it's very close. Okay, it's very close. Okay, so that's why we use the slit is very small. It's very small. It has to be. Sometimes it's even smaller than the wavelength. Okay. Now last one, the distance between the two slits must be small. 这个 A 也是很小的。OK， 你这样子看到好像很远呢，其实真正它很小的。OK， 一个 plate， 然后它两个在 ，Yeah， it's very small. It's very difficult to see it. Okay, so you have to make sure all these three, then only you can get a very nice picture of this one. Very nice picture of this one. Okay. Now, okay. Okay. Now, next one, the question will also ask you, how do I increase the x? How do I increase the distance between the fringes, the bright fringes? Okay, 其实这个你不用背的，你看啊，我的 formula lambda 等于 ax over d 啊。然后我 make x as the subject， 所以 x 等于 lambda d to a。OK， 我要怎样 increase x？ 我就 increase d， 或者我 increase lambda， 或者我减少 a。That's it. Okay, so I can use a longer wavelength, or I can increase the screen distance d, or I can increase the distance of the double slit a. Then I can increase the x. Yeah, I can increase the x over here. Okay, now last slide is, I think the last one is this one. Okay, this is the last slide. Now, 左边是 okay, the difference between single slit 还有 double slit. Single slit and double slit. Single slit 如果你用一个 slit 罢了，就是比如说你的 laser 啊，这个是你的 laser， 然后这个是你只是用一个 slit 一个 plate 罢了。Double slit Young's double slit experiment 啊，它有用两个 plate 对吗？它用一个 single slit， 然后它又用一个 double slit。这个是 Young double slit experiment 啊。如果我 remove 那个 double slit， 所以我只是用一个 single slit 罢了，这样它就不是它就没有 interference 哦，它就不会有 interference。如果你用一个 slit 罢了 ，OK， 因为你只有一个 wave 罢了嘛，一个 source 罢了嘛，如果你用一个 slit。So there's no interference. So this one, a single slit is actually diffraction only. There's no interference of light. Okay, it's the diffraction. And you see, this one, the middle, the bright fringes is very thick. Okay, because most of the light is focused on the center. Right? You have the slit, you can imagine it. You have the slit, light passes through, most of the light will focus on the center. That's why the center you get a thicker fringe, a thicker region. So the distance over here, and also it's not the same as distance over here. Not same as here. Not same as here. It's all not the same. It's different. That is the diffraction. This is to study the diffraction of light. So for interference on the right, the diagram on the right is when I take a laser. First, I make a diffraction. Okay, I make a diffraction. 然后过后我再放多一个 double slit， 我再放多一个 double slit， 我一定要有那个 diffraction 呢，不然你的 laser 出来是太 focused on one point 了，所以我首先我要弄它 diffraction 先，我才可以放那个 double slit。 OK， 然后那个 double slit 它会再 produce more diffraction， and the diffraction they will all overlap and to form interference。所以 double slit 是 for interference of light。然后 for interference of light 呢，你会看到它的 distance 全部是 equally spaced. This is very nice and uniform, equally spaced. So this is the difference between these two. Okay, so in the exam, how is the question asked? Sometimes they will ask you, okay, identify the difference between diffraction and interference. Then you have to come up all the things. Okay, diffraction is single slit, interference is double slit, and how does it look like? All this. Okay, now, so 我会 send 你们一个example just to practice, just 3 questions. Okay, examples is about the formula lambda equals to ax over d. The calculation ax over d. Okay, now for the revision, we have a class on Tuesday, and I'm planning to add one more class. Okay, I just mentioned this now, but some of you were not here, so I repeat again. So I'm planning to add one more class on Saturday or Sunday, depends on you, depends on your availability. Okay, and these 2 classes I will mostly focus on the revision only. Okay, revision, meaning that the first hour maybe I'll give a walkthrough of the whole chapter. Okay, just quickly go through what we have learned and what you need to memorize. And then the next hour is I will give you some past questions to do of the previous exams, past questions in the class. We'll do it in the class together. Okay, so later I will ask you guys what time you guys prefer. Okay? It all depends on you. It all depends on you. It depends on you guys. Whether you want to, what time you want to do it, okay? And whether you want to do it or not. Okay, so yeah, we still have time. We still have 15 minutes. So I'll send the exercise to you and you try it out in class right now.